Hello everyone, this is K.Naga Suresh, Assistant Professor, Department of Mechanical Engineering, Aditya University. Today we are going to discuss about that projections of solids in engineering graphics. So these are the learning outcomes we learn from this topic. Draw the projection of a pentagonal prism in different positions by using AutoCAD software and solve the simple problem related to the projection of a pentagonal prism. And next one, so what is the meaning of projection of solids? The projection of solids is the method of drawing the orthographic views, that is front view, top view, side view of the three-dimensional objects. Like there is a different types of 3D objects like cube, prism, pyramid, cylinder and cone and sphere. So these are the 3D objects. When they are replaced in different positions with respect to the reference planes, so that reference planes are called it as a horizontal plane HP and vertical plane VP and profile plane, that is called side plane or perspective plane. So these are the projection of solids. So this is the simple problem related to the projection of solids in pentagonal prism. Draw the pentagonal prism of base side 30 mm and axis length 60 mm and rest on the HP, on one of the base corners with base edges containing it equally inclined to HP, with base corners with base edge. The axis is inclined to 45 degrees to HP and parallel to VP. Draw the projections of the prism. This is the problem. Here they are given pentagonal prism. We know that pentagon, hexagon, heptagon, octagon, there is a different planes are there. So pentagonal prism means which is having a 5 sides, and the side, these each and every side is equal length. The side is 30 mm, they are given in the problem, and axis length is 60 mm. So that is the height of the prism. Rest on the HP. How it is rest? It is rest with one of the corners. Yes. So here this is the pentagonal plane. So this is side and these are the corners. So these are the corners. So it is resting on one of the corners with base edges containing its being equally inclined. That means if it is plane, it will be placed one of the corner with base edge with base corner, it is equally inclined. So this is the theta angle, this is also theta angle. So not equally inclined means this is not equally inclined. If it is theta, it is here the angle will be changed, that is pi. So there is a different angles, that is unequal inclined. So here they are asking equally inclined means these two edges are equally inclined and it is resting on one of the corners on the HP. So this is the problem. Here there is a two stages are there. In first stage, the axis of the prism perpendicular to one plane and parallel to another plane. This is the first stage. After that change of position method, we change the axis. That means we give some inclination, that is 45 degrees, or we give some inclination with the theta angle. So that is the second stage. In first stage, axis perpendicular to one plane and parallel to another plane. In second stage, axis inclined to one plane and parallel to another plane. So here we observe that this is the 3D planes. In that 3D planes, they are placing one pentagonal prism. So this is A, B, C, D, E. Okay, and these are the prism, it will be resting like that. So this is the prism. So this is 1, 2, 3, 4, 5, 6. Yes. So when you are seeing the front view, okay, so the rectangular faces are visible, and whatever the points are there towards the observer, it is visible, that is A, B, C visible, 1, 2, 3 visible. And what about that DE is not visible, that is far away from the observer, and 5, 4 is not visible. Yes, these are the not observing point, are not able to watch that points. So that is away from the observer. So these are the position, the prism, that means the prism will resting on the horizontal plane like this. The prism will resting on the horizontal plane. So this is the plane and this is the vertical plane. Yes, this is horizontal plane and this is vertical plane. Let us imagine the top plane A, B, C, D, E. So this is 1, 2, 3, 4, 5. So these are the prism. So how we can draw this prism by using AutoCAD software, we will learn. So this is the first stage. So these are the axis of the prism. In that axis of the prism, it is parallel to VP and perpendicular to HP. Perpendicular to HP. The axis is perpendicular to HP and parallel to VP. So this is the position. This is the first method. In second method, so what they are doing, the axis, the solid axis will give inclination. So the prism will give inclination like this. Okay, so that is the angle theta 45 degrees and it is parallel to VP and inclined to HP. So this is the phenomena of the prism. So these problem, how to solve this problem by using AutoCAD software, we will learn now. Okay. See, this is the AutoCAD interface. So first, before starting off any drawing, we will do some screen settings, that is units, 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 enter, and precision change it into 0.0, and millimeters, the units is there in millimeters or not, just cross verify. If it is there in millimeters, click OK, or otherwise if it is there in another units, change it into millimeters and click OK. This is the first screen setting. Next, LIMITS, limits, enter, 0, 0, enter, 420, 297, enter, Z for zoom, enter, A for all, enter. Yes, this is the second screen setting. And third screen setting, D enter, that is dimension style manager, D enter, go to the modify, and in that modify, so symbols and arrow, the arrow size is 4 and text height is also 4, and primary units change it into 0.0 and click OK and close. These are the three important screen settings. After completion of these three screen settings, we will start the diagram. Okay, first take the construction line. First take the line command, L enter, L enter. So it will specify the point. Click on the screen, drag the mouse. It will move any inclination. Make sure switch on the ortho mode F8 for straight lines. Yes, draw the construction line with any length. Next, take the multi-text command, MT enter. Specify the one reference letter for that. Okay, so these are the multi-text command. So give some X and change the letter size 5, enter. Okay, copy this letter, CO, enter, select this letter and switch off the ortho mode F8 and place the axis letters here or construction line reference letters here. So double click on the letter, the editing option is open. So give Y and X and Y coordinates. After that, so we'll start the problem. Where we start the problem initially. So here the true length, so here the true shape is visible in top view. Okay, in front view rectangular faces are visible in prism. because it is resting vertically on the horizontal plane. So where we can identify, so if it is a hexagonal prism or pentagonal prism, in front view it is not possible. So if you observe the top view, the shape of the polygon, based upon the shape of the polygon, we will identify the which type of the prism they are given. So in the top view, the shape of the prism or the shape of the plane will be identified. The shape of the plane is pentagon. So the name it called as a pentagonal prism. We can observe the true shape on the top view. So first we draw the top view. The top view is coming below the XY line. Go to the polygon command. It is available in draw toolbar. Go to the polygon command. Okay, and it will ask the number of sides. Give 5, enter. Okay, and take the edge command. The edge option available bottom of the screen, or E means edge. Edge E, enter. Click on the screen, drag the mouse. Okay, so make sure switch on the ortho mode F8. Okay, what is the side they are given? 30. 30, enter. Okay, so after that give the mark the 5 points, copy the letter, copy any letter. Okay, switch off the ortho mode and place the letters. And here, so in that prism, the top plane is visible, that is A, B, C, D, E. The bottom planes are not visible. The not visible plane points are, keep it in the bracket. So this is A in bracket 1. Next one, this is B and in bracket 2. Next 3. Double click on the letter, it will be editable. C in bracket 3 and D in bracket 4, and next one E in bracket 5. So this is the top view of the prism. Yes, and after completion of that, take the line command and draw the projection lines. Project all points above to draw the front view. So in that front view, so take the PL command, that is called polyline command, PL, enter. What is the height they are given prism? So the height is 60. 60, enter. Make sure switch on the ortho mode and trace this point for calculating the width and complete the front view of the prism. Yes, so this is the prism. This is the front view. In this front view, total 5 sides, 5 rectangular faces, only 2 rectangular faces are visible and remaining 3 rectangular faces are back side of the observer, we cannot able to see. Yes, so give the notations, copy letter, switch off the ortho mode, and the top plane we assume it as a B, C, D, E. So this is A, B, C, D, E tracing points. Yes, so this is what. So if you see the front view, B, C, D is visible, E, A is not visible, and A, B is coming in same common baseline. So this is B dash. So in front view we indicate like a dash, okay, and A dash. So what we are unable to observe, we cannot able to see the back side of the points, that letters are put it in the bracket. And this is C in bracket E, C dash in bracket E dash. And next one, this is D dash. Then after, give the same notation, take the copy command, CO enter, select these letters and copy here. Yes, double click on the letters, it will be editing option is open, and this is 2 is visible in front view and 1 is not visible. Here also 3 is visible and 5 is not visible, and here 4 is visible. Yes, so this is the marking positions or marking points of the front view of the prism. After completion of that, draw the axis line of this object. So go to the properties, here bilayer option is available, go to the bilayer option and go to the others. So the layers window is open here, go to the load and here different lines are available. Here select ISO long dash short dash line is available. The line number is ACAD underscore ISO 08W100. This is the line code, ISO long dash and short dash. So select this letter, select this line and click OK and draw the one line here from here to here. Yes, so select this line and go to the bilayer and change the line style to axis line. Yes, so this is the axis line. Yes, after completion, this is the first stage top view, first stage front view. Yes, one axis of the solid is perpendicular to one plane, parallel to another plane. Yes, so this is the first stage, and next stage the prism will give inclination, the axis of the prism will give inclination 45 degrees. In this situation, you can tilt the prism, it will be resting on one of the corner of its base on the ground. So here if you are observe, so this is the prism, if you give the inclination in this direction, it will be resting on point 4. Here this is the point 4. The point 4 is one corner of the prism. If you tilt this direction with the 45 degrees, so it will be resting on point 4. The point 4 is nothing but one of the corner. Yes, so tilt the axis in this position, okay, with 45 degrees angle. First, before the given inclination, first copy this front view in this position. Take the copy command, CO, enter, select entire this front view object, enter, and copy here. Yes, and so this is the front view position. Yes, so after that give the inclination 45 degrees, take the rotate command, RO, enter, that is rotate command, select entire object, and rotate 45 degrees. Yes, so this is the clockwise direction, we can give minus 45. Yes, so after that it will be resting on one of the corner of the base on the ground with the base edges equally inclined, that means it will be resting on the fourth point. Take the move command, so it is available on the modify toolbar. So take the move command, select entire object, and pick the fourth point, that is corner point, place on the ground. Yes. So this is the object is resting on one of its corners of the base on the ground. After completion of this second stage front view, project each and every point below by the help of a line command. That lines are nothing but projector lines. Make sure switch on the ortho mode for drawing the straight lines. If you switch off the ortho mode, maybe inclined lines are came. So these are the projection lines from the first stage top view. So why we project these lines from the second stage front view and first stage top view? To draw the second stage top view. Based upon these intersection points, we draw the top view of the second stage. Yes. So project the axis of the solid also. Yes. And here these are, we change it into axis projections. Okay. So first, when we see the top view after giving inclination, the top plane, pentagonal plane is clearly visible. So first one, go to the PT, point style PT, enter, change the point style and give the point size is 3 and set size absolute unit, click OK. Yes, take the point command, PO, enter. Okay, so where is A? So this is the A from the first stage top view and this is the A from the first stage top view, both are intersecting here, you will give 1 point here. Again this is B from the first stage top view and this is B from the second stage front view, both are intersecting here, you give 1 point here. Again this is C from the first stage top view and this is C from the second stage front view, both are intersecting here. Likewise you coincide the similar points, this is the D and this is E. Yes, and take the PL command, that is called polyline, PL command, PL, enter, zoom it carefully for joining purpose, A, B, C, D, E, again A. Yes, when you see the top view, these edges are visible, that is the BC edges and AE edges and AB edge is visible, ED and CD edges are not visible, it is underside of the prism, that is not visible points. Take the point command again. So this is the first point of the number 1 point from the first stage top view and this is the number 1 point from the second stage front view. Give 1 point here and this is the point 2 from the first stage top view and this is point 2 from the second stage front view. You give 1 point here. Likewise, you match the similar points. This is 4 and this is 5. After that, give PL command, PL, enter. So this is 5, 1, 2, 3 and again command is closed, again you give polyline command, PL, enter. So this is 5 to 4 and 4 to 3. Yes, so 2 polygons are completed. Next one, draw the vertical edges, PL, enter. This is one vertical edge and this is one vertical edge, and this is also one vertical edge, and this is also one vertical edge, and this is also one vertical edge. Yes. So, after this is the second stage, top view. Give some points, mark the points here, copy any point here, make sure switch off the ortho mode. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, again this is 5. After that, copy this all letters and move for next position. So, this is A, B, C, D, again this is E. So, this is the top plane marking points. After this is the final structure. After completion of this, you give the dimension system, take the linear and give the edge dimension. So, this is 30 and again give the axis height 60 and give the inclination, go to the angular, give the angle 45 degrees. Yes. So, after completion of this, we need to show the difference between the projection lines and product. So, you need to give some thickness of the product. So, how we can give the thickness of the product? By using poly edit. So, that is command is PE enter, select the object and some commands are opened, that is close, join, width, edit, vertex, fit, spline, decurve, like some commands are open. Here you select the width and the width size is 0.8, you give 0.8, enter. Yes, and press enter button 2 times, the same command is continued, 0.8 and press 2 times, the same command is continued. Give some thickness for better understanding and you know the difference between the projection line and product. So, it is very important point to show the difference between the projection line and product. You press the enter button 2 times, the same command is activated. After completion of that, so some of the edges are not visible after giving the inclination. Yes, so this bottom corner edge point is not visible and these two edges like bottom edges, that is 3, 4 and 4, 5 is not visible. You will convert it into dotted line or hidden line. So, go to the bilayer and go to the others and here go to the load. Here one line is there, that is the first line, ACAD ISO 02 W100 ISO dash line is there. Select that line and click OK and OK. So, whatever the edge you are unable to observe, so that is the hidden edge, you will convert it into dotted line. So, go to the layer, select that line and go to the line. Go to the line, select that line and go to that hidden line option. Okay, these two edges are not visible, that's why we converted into dotted line or hidden lines. Yes, so this is the today's section to draw the pentagonal prism in the AutoCAD software. Yes, and today we will learn about the what is the summary today's class. Draw the pentagonal prism in different positions by using AutoCAD and simple problem on the pentagonal prism. This is the today's section. Thank you everyone.